Animation blueprints on Unreal Engine 4. Okay, starting off with our blueprints for our animation for our character. We've got the event blueprint begin play. This event triggers at the start of, beginning of play, as it's called. Hooked up to this, we've got a montage play, which we've got a montage. If I load up now, I can show you it. So that was our animation we use for our montage we use for our event begin play. Okay, moving on is our event blueprint initialization animation. This is the same as the begin play. Once the character is loaded in, these two events fire at the same time. However, this time we we hook our initialization up with a cast test, in which is our blueprint, which is used on the character. With this, however, we have to grab an object, which is our try to get pawn owner, which would be the actual blueprint of the character. From this, then we move on to multiple settings within our animation blueprint. For example, we set our first set is character, which is an object reference within the blueprint. Now, second one is the testing reference, which is a blueprint character blueprint reference. These then go to a bind event to attack an event, which we use with our left mouse attack, which is set up within our character blueprint. Okay, moving on, we've got our event blueprint update animation. This is a event that triggers every frame, which is used to control a logic which decides on which animation will be played for each frame. Okay, after the event begins, we go to an isValid, which we grab our import object from a try to get pawn owner. If our object is valid, we then move on to our setting of our X attack, I've named it, which is a sword attack which our character carries out. And this is the area also we would set some other attacks, which will be controlled using a Boolean option, or Boolean variable. Next we move on to a delay of 0.002 seconds. This was set up because when working on prototyping on earlier stages, I have issues where our can crouch was interfering with our other animations. Basically, the gap added in just separates this and our rolls, which I'll move on to next. Okay, no delay once again. The same thing as the one before, just separates the two sections so they don't have issues with each other. Okay, setting our roll left, roll right, and roll back. These are booleans that are set up within our blueprint or animation blueprint, and the true or false variable the value is obtained through our testing reference, which is referenced back to our testing blueprint, where inside we've also got a dodge back, dodge left, and dodge right, and a can sprint. These all hook up then into the input slots on each set, which then gets sent within the blueprint. I'll come back to the notified dodge finish later on, as it is something to do with the anim graph and animations that get carried out inside it. However, the setting is carried out similarly to shown above, using instead of, ignore what I just said, it wasn't the same as this, it's the same as these. However, instead of getting, we're setting them. Okay, next is our set is in a basically we get our pawn owner, we get his movement component, which controls his movement. Then we see, is the character falling, and if it is, if it's true, that we set is in true, or if it's false, we say a false. This is used once again for logic in the anim graph, which I'll go into later on. Okay, get velocity. Same thing again, but this time for speeds. So we get our character velocity, get the vector length, then return that value as a integer. No, as a float, sorry. With our floats, we get a solid number, which is rounded to equal. No, it is given to. It's a number given to decimal points. For example, I'll show you now. Using this, I can show you. So, floating point number contains fractional parts, so we can get, for example, 10.89, or number shown in the current text. Okay, moving on to our set, roll, pitch, and yaw. To get these, we once again get our player, our pawn actor, get pawn owner. Sorry, God. We get our base anim rotation. Get base aim rotation, which is based on the direction the actor is looking in. Get actor rotation. Almost similar things, but okay. With these, we combine them into a delta rotator. Then, using the return value from now, we break the delta into floats, where we get a number which can actually, well, used in not regular number form with decimal points, well, decimal fractions. So our roll, so our x direction, our pitch being a y, and the yaw being our z. Okay, moving on, this time is our yaw delta, which is used as chosen for our leans. So as the character runs, it'll lean to either side. Okay, this is once again get pawn owner. Moving to our get actor rotation, which gives us a rotator value, return value of a rotator. We put the return value into our delta, as it being the B input. Also, rotation last tick, which is obtained through pretty much the get actor rotation, where we input however not into the delta rotator, but the rotator set called rotation last tick. With the delta rotator, then we break the rotator once again into our yaw, our B now Z. We then get our, then we divide it then by we divide our yaw by our delta time x, which is I believe frames per second. Then once again divide that number we just obtained by a solid 7, which is our lean intensity scaling. With this we get our yaw delta, it's our current interp 2. The number we just obtained was our target. Our delta time is obtained from our update animation node. Using an interp speed of 6, we get our return value for our yaw delta. Okay, moving on to our next section. It's accelerating. To get this, we cast our character, with the object being get pawn owner. And we basically get set node being is accelerating, which is a boolean variable, so we can only get true or false. And to decide whether we get true or false, we as the cast, we get our character movement, get current acceleration, return the vector length into a float, and compare our flow to 0, which would be stationary. So if it's 1 or more, or 0.1 or more, we'd be currently accelerating. Like I said previously, all this will be then shown off in our anim graph, as all this is logic to control which animation is played per frame. Okay, now we go ahead across this way. So we get this is to control our direction. Well, gyro direction, I should say. Similar to how we set up our yaw delta nausea. Similarly, anyway. So we get our aim rotation, bring that into bring the return value into a delta rotator. We get our velocity, we go in, get the rotation from the x vector of the return value. Then plug that into the B input in a delta rotator. With the return value we get then from the rotator we break, getting the yaw from it. Times that then by a negative number, or -1, which will flip basically gives this, so the number we get is between, well, as I set up was, we'll go to -180, which will be our left, and positive 180 for our right. Without the negative times, it would be the other way around. Slightly confusing. Okay, then we move on. Well, let me set the direction. This will then be used in our anim graph later on. Okay. Then we set our full body. So we get curve value, which is a curve name of full body. This will be explained later on in the anim graph. Return value of we get the return value and put it into a greater than of 0, and then while comparing it to 0, then setting our full body. If it's below 0 is false, if it's larger than 0 is true. Okay, now we move on to our branch, which controls our max walk speed in animations. Okay, so problem I was facing with slight problem I was facing while working with animations was backwards running. Basically, it'd be a stutter after a short duration of running backwards. So to try and fix that, I had to set up I'd grab the direction. If it was below -135, it would set max walk speed to 400. Similar if it was above 135, basically going in a backwards direction. However, if false, if these return back false, it would keep our default max walk speed of 600. Okay, stop. Okay, that's important. Okay, notifiers. Okay, we can head on to these now. Basically, with our default attack, we've got 3 different default attacks our character will carry out in combo. In these, we've got set up anim notifiers where we can save the attack. If, for example, we attacked once, then within the set period of time before the notifier triggers again, we can set a save our attack, which will allow us then to carry out an extra attack afterwards. So this is set by getting our pawn owner cast into our testing blueprint and executing a combo attack save event, which is within the testing blueprint, and the reset combo is exactly the same below. Okay. Another thing I wanted to set up this time with the X attack was basically stop the player from moving while setting off his attack as his spin attack. Well, sort of, anyway. So I cast our testing setter. Okay, so this is our animating. So the other part of this is set up within the testing blueprint, which was easier to work with. So we cast our test in, set our X attack to false, similar to our sword attack to false. I set our max speed back up to 600, bringing it back to regular walking speed and running speed. Okay, so this covers everything. I need to go over now logic section of this animation blueprint, so our event graph. Now it's time to move over to our anim graph. Okay, this is split into 4 sections. We've got our jog run, locomotion section, our offset and extra movements like rolls, jumps, attacks, an upper body layer which is used, for example, with the basic default attacks, as we can, for example, use now jog run animation. We separate the top end of the spine with the lower end of the spine, allowing us to use the top end of our character for our sword attack, while our bottom half of the character for movement still. So I'll go for that as for this third section. The last section is the IK section, which basically is extra set of bones on characters, which dictates their movements along basically ridges, so foot placements isn't like floating in the air. I'll cover this in the last section of this. Okay, so moving back up to the jog run state machine. Okay, so animations are controlled within state machines. I should start off with. Within a state machine, we can set up multiple states, conduits, and comments. So we can comment out, for example, all of this if needed be. But however, we don't need to. So we've got our idle animation set up. So for example, if we're not moving, so that'll be our idle. Our jog start is dictated through a speed and is in air. So if we're not in air and our speed is above 0, we'll then start to jog. Then from our jog, we'll move straight into a jog start. We'll move straight into a jog animation, which is controlled for a blend space, which I shall cover. So our output animation pose is controlled for a jog combat, one of the blend space I created. Within this, we've set up a jog forward animation, jog straight left, right, and backwards. So going back into the animation, this is controlled for a direction. Float we've got, which gets our direction, which is then internally basically the direction value we get is placed between back all the way up to forwards animation, and it's above, positive, or below, depends whether we go left or right. So back into our locomotion, we've got our jog stop. This is controlled for a so to enter this animation, first off we go apply to a condition of is accelerated not. So basically this is saying is our accelerating value false? If so, we can move into a jog stop. Similarly, we can do this from a jog start into a jog stop. So jog stop, basically similar to the previous one, we can do it based on direction we stop in. So if we stop pen left, we can do that. If the animation plays, basically this acts a similar way to our jog in blend space does. Okay, this is our locomotion state machine. Basically that's all there is to it, which then we save this as a ground loco, which basically this allows us to carry on into another section. So using our so we would use this ground loco, go into our next state machine called locomotion jump. and set our idle jog using the cash pose, which is ground loco. Okay, this is a lot bigger than the previous one, as it's got a dodge, X attack, crouch, and jump. Okay, so I guess I'll start with the dodges, as pretty much they said pretty much exactly the same as each other, being idle jog to dodge left is controlled through if our roll left's boolean is true. If it's not, it doesn't go through. And if we've gone to this state and our boolean returns as false, we head back into the idle jogs. Within these, all animations are just basic, nothing's done to them. And then they're just placed into the output in the animation pose. These are set up exactly the same, each one basically how go into their own respective booleans. That's basically my dodge system. More complicated setup in the testing blueprint, however. Okay, moving on to our jump now, I guess. This is controlled through an is in air, and if so, we play our jumps. So we go jump start animation. This then moves into a jump apex and jump pre-lands, each just holding their own animations, and follows the automatic rule. So once each animation is played, they'll just play through. Once that's done, we go to that can be looped. However, if we go return back to not is in air, we go to our jump land animation, which is a blend between ground loco and jump recovery additive, which is just this. Not much really to say about it, it's just impact of landing, well, recovery. It's basically blended over each other. Then we move back into our idle land through just the automatic rule. Okay, next we'll move on to our crouch. This is basically set from a boolean, so can crouch true and can crouch false. Within this we've got a 1D blend space being just crouch with no movement or crouch with speed applied, so basically just moving forward. That's all there is to my crouch. Then next will be our X attack. This is controlled through if X is true, we can move into the animation. However, if it's false, we'll move back out. So our X attack being called ability R from our animation saves. Okay, so that's our locomotion jump. So this state machine then plays into our idle aim offset, which are yaw and pitch controls. Basically our offset of the character. This saves then into our another loco pose. So this then is used in the upper body layer as a cache. So we use our cache loco pose, add our upper body slot, then cache our pose as upper body. We then use the cache pose loco pose, upper body as a blend. So if full body is false and is accelerating is true, we set our active values. So if this is true, we'll use our upper body blend. If it's false, we'll just use our cached upper body. And this then goes into a cache called full body pose. Okay. IK system. So using our full body cache, we set this to a local component using a leg IK nodes, where we set up our two IK sets, being our foot bones and hands. Right. No, just our foot bones in this. Basically, this controls our foot placements, so we don't have any floating parts, or floating feet anyway. This thing fits our command space to local pose and gives us our final animation pose. So, like I said, all of this is controlled through logic previously gone over in our event graph. This pretty much covers my animation setup I've got for my current character as of, well, recording this video. Any other features I add in will possibly explained on the blog post, or this shall be the final edition. However, before I end things up, let's show off the character in some gameplay. So, should probably show off first the. Oh, okay. This is a mess already. So, showing off. So that was basically our spawn, controlled through our initialization. No, begin play animation. We set up the blind space. So moving forward, strafing left, strafing right, and stopping. Moving backwards. Move forwards while attacking. X attack. Trying to move forward and trying to do an X attack. Like I said prior, setting a tested blueprint, so if X attacks getting carried out, the character is unable to move. We've got our jump. We've got our crouch. Oh, crouch does not work while trying to run. Note to self. So crouch movement. That's all the animation setup. So I've showed you. Oh wait, no, I haven't showed you the dodge left action, dodge right. So dodges. Anyway, hope you find this video informative. It's probably you should probably follow the rest of my blog on updates of my progress. Anyway, thanks for listening.